Alright, good day. So what we're going to look at next is rules that only work for the right angle triangle. So once it have that box in the corner there that indicates it's 90 degrees or a right angle, these next set of rules, and we have two main rules. The Pythagorean theorem or Pythagoras' theorem is one of them, and the next one is the trig ratios. So over 2000 years ago, this Greek philosopher Pythagoras would have realized and come up with this relationship, or at least he was credited with coming up with this relationship in the right angle triangle, which is a relationship between the three sides in a right angle triangle. And what he realized was, or was credited as realizing, is that if he was to square the hypotenuse, the longest side of the right angle triangle, that was the same as squaring the base, squaring the height, and adding them up. So if I was to square the base, square the height, and add them up, that's the same thing as the hypotenuse squared. Or in terms of what we want to do, we could use this to find unknown sides in my right angle triangle. So in other words, if I have two sides of my right angle triangle, it don't matter which two, I could use this relationship to find the third side. So we normally rewrite this because I want to find one of these sides. So to get the hypotenuse, because I wouldn't want the hypotenuse squared, I might just want the length of the hypotenuse. The reverse of squaring something is the square root of base squared plus height squared. Right? And you have different variations in this. So in some textbooks you might see a squared is equal to b squared plus c squared or something like that. All of that refers to Pythagoras' theorem. So this here is really what you need for Pythagoras' theorem, and it's just a relationship between the three sides in your right angle triangle. It must be a right angle triangle. Let's see how this would look with an example, a very basic example. All the examples are using going to give me whole number answers, but obviously you'll get decimals as well. I'm just doing it for ease of use for these examples. So I have a right angle triangle. They give me two sides and they want to find the third side, and once that is the situation, I could use Pythagoras' theorem. So I like to label. So let me label the sides of my triangle. Opposite the 90 is always the hypotenuse, and it don't really matter which these two because we're going to change the orientation sometimes. But in this example, this is going to be the base, and this is going to be the height. Again, I just shortening hypotenuse with HYP. So the formula is, and it's always good to write back what you're using so you're less likely to make a mistake. The hypotenuse squared will be the base squared. Again, I just shortening base with b plus the height squared. So let me put in what I have in this formula. So the hypotenuse is x. So x squared will be the base 3 squared, so I just substituted it into my formula now, plus the height, which is 4 squared. Let me work out what I could work out. Square means multiply by itself, if you remember. So 3 squared is really 3 times 3, so this is 9. 4 squared is 4 times 4, which is 16. So I have x squared is 9 plus 16. 9 plus 16 is 25. Now remember, I asked you to find x. I didn't ask you to find x squared, which is why at some point using Pythagoras' theorem, we always have to find the square root, which is just a button on your calculator. The button on your calculator actually going to look like that. So it does look like this symbol there. You just look for it on your calculator, and that's why you need to get accustomed to how your calculators work and not only use your phone, because for the exam, you need to know where these buttons are on your computer, your calculator, and how to use it as well. So x squared is 25. So x will be the reverse of squaring something is to find the square root. The square root of 25. Square root is the reverse of squaring. So some simple ones like these you might be able to do in your head. And this is a very popular ratio. 3, 4, and 5 always go together. So x is really 5 meters. We find the length of that third side without actually having to draw and measure it ourselves. And 5 5s are 25. So if I was to do the reverse, 5 squared, 5 by 5, 25. So that's what the square root button will do, and if you did that on your calculator, it will come up with 5. Let me look at the next example. So same idea here. I like to label the sides first. I have two sides. I want to find the third side. You realize no angles in play. That'll come more when we do in the trigonometry aspect. So opposite the 90 is the hypotenuse. The one on the bottom we normally call the base if you put the triangle to stand upright, and this will be the height. So the formula again is hypotenuse squared will be base squared plus height squared, or height squared plus base squared. It doesn't really matter which one comes first. So the hypotenuse is x, so that will be x squared the base is 5 squared, the height is 12 squared. So this is x squared is equal to 5 by 5, 25. 12 by 12, 144. So x squared is 25 plus 144, 169. Sorry, I forgot all the squared. So x, because I didn't want x squared, the question asking for x will be the square root of 169. This one I might know at the top of my head, so that's where the calculator will come in handy, and you double check it yourself. That when I put in square root 169 in my calculator, that it comes up as 13, which makes sense. Because if you notice, the definition of hypotenuse, which we would have seen when we did the right angle triangle, it must be the longest side of the triangle, meaning this side of the triangle is longer than any other side. And in this first example, 5 meters is longer than 4 meters, 5 meters is longer than 3 meters, making him the longest side of the triangle. Same thing here. This was the hypotenuse, meaning he have to be the longest side. 13 meters is longer than 12 meters, which was the height. 13 meters is longer than 5 meters. So he's supposed to be the longest side of the triangle. Let me look at one more example that I'm going to work out. So in this one, just like before, opposite the 90 degrees is always the hypotenuse. That's how we find the hypotenuse. Opposite the biggest angle would be the biggest side. And in the right angle triangle, the 90 degrees is the biggest angle. So this becomes the base, and this becomes the height. So let me write out my formula again, because two things beneficial for writing out the formula. You're more likely to remember it, and you're less likely to make a mistake as well, which is why we should write out the formula. So you'll get accustomed to writing it out. So hypotenuse squared is the base squared plus the height squared. And let me start putting it in. So what's the hypotenuse in this question? So don't always assume that the hypotenuse is going to be x. The first two angles, yes, they were x, but in this one the hypotenuse is actually 10. So 10 squared, the base this time is x squared. Excuse me. Plus the height is 8 squared. And let me, just like before, work out what I could work out. 10 squared means 10 by 10, which is 100, is equal to x squared plus 8 by 8, which is 64. So unlike when I did the others, x was already by itself, and I can't solve something unless x by itself. So I need to get x by itself, and this is where algebra keep coming in. Algebra don't disappear. Algebra always going to be around. So if I want all the letters on one side, all the numbers on the next, that means the 64 shouldn't be here. I'm going to send them across to this side. But when I send across plus 64 to this side, it's going to become minus 64. So I'm going to get x squared is 100 take away 64, which is 36. So I have x by itself now. So if x squared is 36, then x is going to be the square root of 36, which is what times what going to give me 36, and I have to be the same number. 6 meters. Let me see if that makes sense offhand though. One, if I was to add these up and get 164 and find the root of 164 and get 12 point something, or almost 13, which is what is the most common mistake when we normally do this in our class. 13 would have been longer than the hypotenuse. Remember, the hypotenuse is the longest side of a triangle. So how could this base, which is not the hypotenuse, be longer than that side? So I already know my answer because I had the hypotenuse, that the other two sides would definitely be less than 10. This was already less than 10, so I was expecting this to be less than 10, and it was less than 10. So what I would like you to try, I'm not going to work these out unless all request me to work them out. I have a triangle here. You try this one yourself. I already write the answer on the side here, but I want you to try it and see if you come up with yourself. In this one, you realize the orientation change of the triangle. This is still going to be the hypotenuse. We could still check this as the base. We just kind of flip it, and this could still be the height, and you have your numbers. Because really, these two interchangeable. It doesn't matter which one, because both of them going on the same side, but the hypotenuse is always separate. So try this one. Write it in your book. You could pause the video here, try it, and see if you're getting that one. And when you finish that one, same idea here. You try this one and see if you get in the 7. So you could pause the video here, copy down the question, try it, and see if you get in the 7. Alright, so those are 2 for you to try and see what you get. Up next, the second rule, which is the trigonometry aspect.